Now let's talk about communication. Let's jump across the chasm of ignorance where we don't even know of life elsewhere in the universe, and imagine that life does exist. And imagine that some fraction of the microbial life out there beyond Earth has progressed to the level of intelligence and technology as we have. How would we communicate with it? The universe is a big place, and in the totality of all the habitable worlds, we might imagine that some fraction of them will have generated intelligent species with the capability to travel in space and communicate through space. So humans and scientists have imagined this possibility, and they've started to speculate how to understand it. It's formalized in terms of the Drake equation, named after a famous astronomer at University of California in Santa Cruz. The Drake equation is a series of multiplicative factors designed to combine to estimate n, the number of currently communicable civilizations in our galaxy. The first three terms are actually now measured. R is the star formation rate, that's how many new planets with life on them are emerging every year. F is the fraction of those stars that have planets, because they might not all. And N is the number of planets in a system that are Earth-like. Those have now all been measured by astronomers. The last three F factors are unknown, and the L factor is unknown, because these are biological and cultural. FL is the fraction of habitable planets that actually have biology. Fi is the fraction of those where that life eventually becomes intelligent after some time, and Fc is the fraction of those where technology and the ability to communicate is developed. All of it is multiplied by L, the lifetime of that civilization in the intelligent communicable state. In our case, we're not sure what L is. We've come close to self-destructing with nuclear weapons, and we might yet destroy ourselves, meaning L might only be 100 years. But if a sophisticated, intelligent civilization is also wise, perhaps L is thousands of years or millions of years. So you can see that N, the answer to this equation, while it's unknown, could have an enormous range. So we have known and unknown factors. Maybe Frank Drake knows, but I actually think nobody knows. We can imagine it in this way, too, to visualize the real estate of the Drake equation. It starts with a huge number, the number of stars in the Milky Way. And then we've measured the fraction with planets that are potentially Earth-like. And that's a large number still. The fraction that are truly habitable in their habitable zones is another factor smaller, but it's still an enormous number, 10 or 20 billion. And then we become uncertain. Do we think that 1% of habitable planets actually get life? Remember, they all have the potential for life. Or do we imagine that it's 1 in 2, in which case we'd have 10 billion planets with life on them? What fraction of those eventually become intelligent? Is it 1 in 10, or here 1 in 100? Even if it's 1 in 100, we're still only down to 100 million. And again, if only 1 in 100 of those develop technology, we still have 1 million planets with intelligent civilizations on them able to communicate. It's a fantastic number. But if these later fractions are very small, then the product of all those factors could be 1. We might be unique in the Milky Way. That's still logically allowed by the data, because we have no data on some of these issues. Meanwhile, we've tried to do the experiment. This is the plaque that was attached to the leg of the Pioneer spacecraft, and you can see it's a pretty obvious, graphically challenged attempt to communicate our situation. The silhouettes of naked figures causing some consternation in women's communities because the guy's got his hand raised in greeting and the woman's like, okay, I'm with him. What's all that about? There was also complaints to NASA that this was sending smut into space because there was no clothing. But if you're going to put clothing on them, what clothing would you put on humans? The 1970s clothing of the time, that would look pretty out there now. We see a pulsar map on the left that's supposed to triangulate for people who knew pulsars where the Earth was located. We see an obvious solar system model at the bottom with the trajectory of the spacecraft and a silhouette of the spacecraft on the upper right. And then at the top left is the hydrogen atom, indicating the fundamental ingredient of the universe. So this was an early message in a bottle, sent out now into interstellar space, with no real prospect of reaching another star system from less than 50,000 years from now. We also sent a record. The sound you hear is one of the 89 languages with greetings from the Earth. That's Quechua. So there were greetings from the Earth, from the UN Secretary General of the time. There were also photos digitized onto this record. To get as much data on it as possible, it's actually a lower than low playing record. Instead of 33 1/3, it's 1/2 that frequency. The information is contained in the grooves of the record, and it's gold anodized to last a long time. The group that designed this record, of course, got pushback. Why are you sending a record into space when that's an obsolete technology even on the Earth? Although, to be fair, records are making a resurgence. The team that designed it pushed back, noting that our digital technologies, like CDs, are already degrading and information is being lost from them, whereas the analog technology of a long-playing record, with information coded mechanically and in an analog way in the grooves, if the intelligent civilization receiving it knew how to get it out, would last 100,000 years. So these are our attempts to communicate so far. But think of the issues and think of the problems. Here's a species with which we share 99 or 98% of our DNA. We can look into its eyes and see intelligence and sensitivity and emotion. And yet we cannot communicate with this species with which we share almost all our DNA. So what hope would we have of communicating with an alien that doesn't have DNA, of unknown function and form? You can see how difficult this experiment really is. Nonetheless, astronomers are doing it. They can listen or they can speak. Most of the time, we're listening. We're listening for optical signals from space, pulsed in a way that couldn't happen from a normal astrophysical event, or radio signals, also pulsed in narrow form that didn't happen naturally and had to be artificially produced. We can assume that detectable technology will be more advanced than ours. Philip Morrison has said that SETI, the search for extraterrestrial intelligence, is the archaeology of the future. If the technology elsewhere is short-lived, the odds of us succeeding in this experiment are very low. SETI is a needle in a haystack experiment at best, and it will fail if other civilizations have not been long enough lived. Meanwhile, the capability of these experiments is increasing, so the people who do SETI, having had essentially 60 years of no success, ET has not phoned home in 60 years, are now optimistic because the bandwidth caused by electronics and radio technology is increasing exponentially. So the capacity and capability of these experiments is improving by leaps and bounds. And in 20 years, imagining a civilization had the equivalent of our pulse lasers and radio transmitters, we could detect them transmitting out to 3,000 light years, a volume that includes 100 million stars. And at that point, if we hear nothing, if the great silence continues, we might imagine that we really are alone. There's also another approach which is difficult to execute, which is to look for alien artifacts or residues. Notice the problem of the radio and optical communication premise is that it involves active communication. So a civilization has to be trying to communicate as we are. However, a civilization will also use energy, and they'll have waste products for their energy. They may make artifacts which they litter around the galaxy or leave on places they visit. And so there's another part of SETI which involves looking for these. How long would colonization take? Assuming a civilization could leave their planet. And just assume they don't actually go very fast and just make short hops to nearby star systems. At a modest fraction of the speed of light, it would take a civilization about 15 million years to explore the galaxy with robotic probes or potentially to colonize it. And that's an interesting number. 15 million is a large number, but it's less than 1% of the age of the galaxy. And so the question arises, has any civilization got to this point? Has anyone actually done this? And this whole premise has led to an interesting thought. In 1950, the famous physicist Enrico Fermi recognized, even at the dawn of the space age and before any planets had been detected, that our civilization is very young and that we're unlikely to be the most advanced civilization in the galaxy if others do exist. He also knew that a modest extrapolation of our current technology would be able to let us build self-replicating or sentient probes that could propagate through the galaxy, as that little animation showed. And he also anticipated astrobiology, that there are many likely sites for complex life, and plenty of time for technology to develop, even for the billions of years before the Earth formed. So civilizations could have a head start on us. There are Earth clones that could have been formed within a billion years of the Big Bang. So an identical Earth-like planet to ours could have had a head start on ours in biology by 8 billion years. And so the question, are we alone, has been reframed into, where are they? It seems like they should exist. There are many answers to the question that Fermi posed, where are they? Some people think they might have already visited. It's possible that they don't exist and we are unique. It's also possible that they're rare, and space is very big, and so we may find it very difficult to communicate and even more difficult to travel. It's also possible they're unrecognizable forms of life or intelligence, or a little damning to our egos that they don't care about us. And there's even a theistic version of the where are they question, which says they created us. As an astronomer, I don't hold to they have already visited. I spend quite a lot of time dealing with UFO questions. And you just need to look at these two bits of data let's have a data-driven discussion about UFOs just for 1 minute. Interestingly, UFO sightings dominate the richest Western countries. Also, they occur in July and August when people are out in the summer. And the dots on the world map here are the UFO sightings. It's fascinating that there are so many UFO sightings in the US, and they just literally stop at the border with Mexico and Canada. It's also fascinating that Brazil, a country with essentially the same population as the US, sees almost no UFOs. Also, the timeline at the bottom shows that UFO sightings are not random. All of the peaks in that diagram correspond to times of either intense geopolitical crisis or intense activity in the space program, like the Apollo moon landings or the first object we landed on Mars. So I think they have a cultural explanation. I don't think they are alien visitations. Many people want to believe. If you want to believe in crop circles as being alien artifacts left to us, then that's fine. But I will hold to Carl Sagan, who said extraordinary claims require extraordinary evidence. Maybe even more likely, to me, is that they're already among us, just biding their time. And perhaps the least comfortable interpretation is that while we like to think of ourselves like this, the aliens might think of us like this. And that's the end of this topic.